In this work, we present the activities relevant to the ground deformation monitoring of the Stromboli volcano through SAR sensors, performed by the Institute for the Electromagnetic Sensing of the Environment, IREA, and University of Florence, as centers of competence for the Italian Civil Protection Department. Stromboli is a persistent active volcano affected by geomorphological processes along its unstable northwestern flank, known as Sciara del Fuoco. Last high-intensity explosions occurred on 3 July and 28 August of 2019. Stromboli's ground deformation is constantly monitored through two ground-based INSAR systems managed by University of Florence, installed on the northern edge of the Sciara del Fuoco, at two different heights, 190 and 400 meters above sea level. Moreover, since 2015 an extensive Sentinel-1 dataset has been acquired from ascending and descending orbits with a revisit time of 6 days. Sentinel-1 data are systematically processed by IREA through the PS-BA-INSAR algorithm to obtain displacement time series. In the following we jointly exploit both space-borne and ground-based INSAR data to better figure out the displacement behavior at Stromboli. Here are shown the displacement mean velocities obtained through the PS-BA algorithm up to the acquisition immediately before the 3 July paroxysm, so covering the March 2015 to June 2019 period. The combination of the line-of-sight maps allows the retrieval of the vertical and east-west displacement components. In the same interval, we calculated the displacement retrieved from the two ground-based systems. It is evident the different spatial coverage with respect to the satellite measurements. The most important aspect is the line-of-sight orientation, which is highly flexible. Indeed, in this case the line of sight is mostly north-south, which is the main blind direction for satellite systems. Accordingly, the availability of both satellite and ground-based INSAR data, combining the displacement vectors in the same reference system, allows to estimate the 3D deformation rates of the lava flows, as well as the erosion rates of the lavas themselves. The 3D maps show that the Sciara del Fuoco is interested by a westward and downward movement. Satellite and ground-based INSAR systems have also a high degree of complementarity that allows us to exploit them in different situations. For instance, the high temporal sampling of the ground-based system allows us to capture the ground deformation that preceded the 3 July eruption, while satellite data do not provide information across the event due to temporal decorrelation. On the contrary, satellite allows imaging the deformation of the southern flank of Sciara del Fuoco, which instead is not illuminated by the ground-based SAR. Finally, it is under development an airborne INSAR system to further improve the ground deformation monitoring on Stromboli. First experiments show the high degree of versatility of the airborne system. 4 interferograms around the island are depicted. This work demonstrates how the combined use of remote sensing data from different platforms allows studying in great detail the morphological variations induced by the eruptive activity and by the geomorphological processes in steep slope volcanoes.